Bridges have been around forever, long before man arrived. But building skills developed and man learnt to work with natural materials, with lots of early timber bridges and then working with stone bridges like the one in the image. And with this, more sizable spans could be achieved, and as you can see, they could carry some very heavy loads. But it's the development of material technology that really brought about major advancements in how far bridges can span. I'm going to give you a few very quick slides, which by no means will list all of the bridges that claim to have been the longest span at some point in history, but it will show you how changes in bridge form and introduction of new materials, how that has helped develop the longest spans. We're going to start very, very early in the year 104 AD. This is when the Trajan Bridge in Romania was built over the Danube River. This is really quite an impressive structure that had a span of 32 metres and had stone supports with timber arches spanning between. Really quite a dramatic structure from considering when it was built and the techniques it would have available at the time to build it. So over the next 500 years, as you'd expect, the maximum span did increase, but only up to 62 metres. And this example was the Yaxchilin Bridge in Mexico. This is a hemp rope suspension bridge built about 600 AD. Quite a common form of construction that we will come back to at the end for a reason that will become clear. Fast forward another 700 to 800 years to Italy. This is the 1377 Trezzo Bridge. And surprisingly, there haven't been any big gains in span in this period, with the maximum span only increasing from 62 metres to 72 metres. This is a great example of a Gothic arch, which is obviously partially collapsed in the image. Arches have been around for a long time before this, but this sort of shows the sort of spans we can now achieve, and these can carry some very heavy loads due to their shape. So will we ever reach the 500 metre span mark? Well, in 1705 we went a little bit further again. We went over 100 metre, broke the 100 metre span. This is again a suspension bridge, but rather than being hemp rope, this one's got iron chains. It was not long after this, in about the 1780s, where there was the introduction of the new material. Cast iron had been around for a little while, but in the 1780s it was starting to be used as main structural members on bridge structures. Probably the most famous cast iron bridge in the world is Iron Bridge in Shropshire in the UK. This was built in 1779, is an iron arch truss, and it doesn't break any longest span records, but it's I've put it here just to show how developments in technology have started to come into play. So cast iron actually proved to be a very good material. One of the downfalls of it, though, was that it was very brittle, and this really restricted realistically how far it would be able to span. And so about 50 years later, saw the introduction in the 1820s, 1830s of wrought iron as a major structural element in bridge construction. And it could be quickly seen after the introduction of wrought iron that the span started to increase. In 1820, the Union Bridge in Berwick in the UK became the longest span in the world, had a span of about 132 metre long, and was a wrought iron suspension bridge. Wrought iron suspension bridges would continue to dominate the longest span, with the Menai Straits built in 1826 in Wales, again as a period where the UK was really dominating in terms of long span bridge construction, this time achieving 177 metres, but still a long way off that 500 metre line that's on the graph. Then we had quite a dramatic jump of over 100 metres in the space of a few years for this time in Switzerland. It was the 1834 Freiburg Bridge, which again, another wrought iron suspension bridge. Wrought iron was only a dominant material for about 50 or 60 years, and it was in 1880 that steel really started to become more regularly used in bridge construction. And the effect of the introduction of steel was dramatic. So in the space of just a few years, we suddenly smashed the longest span record, going from 273 metres up to over 500 metres with the 1890 Firth of Forth Bridge in Scotland. This is a steel cantilever truss and is one of the most recognisable bridges in the world and is still going strong today. Shortly after the introduction of steel came the introduction of concrete as a structural member. This was about the year 1900, and whilst the longest spans aren't fully concrete because of its weight, using concrete decks coupled with steel girders has proved a very efficient composite form of construction and has made dramatic improvements to the longest span records. Within no time at all, the longest spans have been absolutely smashed, from just over 500 metres to just over a kilometre clear span, which is enormous. This is the 1937 George Washington Bridge in New York. It's got a central span of about 1,034 metres and is a steel suspension bridge. So realistically, how far can we span? Because over a kilometre is enormous. There possibly was an expectation that the maximum spans would start to tailor out, but actually they continued at the same rate. And in 1998, the Akashi Kaikyo Bridge was built in Japan. This is 1,991 metre central span and a steel suspension bridge with a steel truss. And it absolutely dwarfed any longest span record prior to that. This record lasted for just over 25 years until 2025, when the 1915 Kanaköli Bridge in Turkey opened. This had a central span of 23 metres. It was a steel suspension bridge and the first bridge ever to have a clear span in excess of 2 kilometres. So let's have a bit of a recap. What is the main reason that spans have increased? Well, there are a number of options written down here, all of which would have some input, but what surprised me in doing this review is actually structural type played a very minor role in that. In the start of the 20th century, the longest spans in the world were generally suspension bridges, and the longest spans still built today are still suspension bridges. The structural form hasn't really had a big impact, but you'll see from the graph that's the introduction of new materials that have help do that. Obviously that's in an industrial era where there is also improvements in construction plants and much more knowledge of the materials, so which all helps, but by far material is the dominant factor. But I'd be interested for you to think about how big they can get. If we carry on at the current rate, are we soon going to get a 4 kilometre long span or an 8 kilometre long span, or are things finally starting to peak? Thank you. I'm That Structures Man. If you like this, then please click like and subscribe.